So all the wrapper classes by default implements the comparable, and that's the thing that's written over here. All wrapper classes and string objects are implementing comparable interface. So that's why if I want to, if I have anything, right, let's create a list of 1 2 and 3, right? So I have created a list of, this is integer I want, so int list, let's name it, and this is the integer list, and let's let's randomly put the values, right? So if I just sys out and int list I'll try to do, okay, let's cut this code and let's create a class temp. I'll delete it in a while. So if I print this int list over here, so it will print the data in the normal order in which we have inserted the data, cause list preserve the insertion order. But if I want to sort, there is a collections class that we have seen in the last session. Collection is an interface and collections is a utility class for collections data, right? So over here I can put my int list, right? And default sorting will be ascending order. Okay, I need to sort it as well. Unsupported, oh shit, list of again non-modifiable list it provides us. All right, no worries, I cannot move the data, so I need to manually do the labor add list, and over here let's remove this thing and new keyword needs to be used, and over here int list dot add 3 or 2, and then int list dot add, okay, earlier it was I guess 2 and 1, and let's add 3, and over here after int list. So over here I have done nothing, I just done collection dot sort and it was able to sort this thing, right? I don't even had to do anything. The reason is the integer class is implementing the comparable. With comparable of the integer it implemented, so it has implemented a method compare to, right? This is the method that we have to implement if we are implementing the comparable compared to. All right, so that's why all wrapper classes implements the comparable. That's why we are able to use the collection dot sort directly on it, but it's the default. Why we call it default sorting order? The reason is we can have only one, because we are implementing with the class which we want to sort. Like with the integer, we are implementing the integer class is implementing the class we want to sort is implementing the comparable. So if with the primitive data structure, or the primitive, I mean the wrapper class is a replica of the primitive data type, and with the primitive data type replica, wrapper class integer has only one value, and that is int. It's going to hold only int, there will be no other value it needs to hold. So that's why comparable is good with the wrapper classes, because they are only going to save a single value. But with complex object that we can create, or we will create, that can be employee, student, or anything else, it can have multiple data like the name, employee ID, and all those things. So if we use comparable with this, then what will happen, like in this example we are using comparable only with employee ID, right? But what if I want to sort the employee with the name, employee name? Then I need to come again to the employee class and then change the implementation over here. Instead of EID, I need to use the name. So with the comparable, there is a drawback that I can use only one sorting logic. If I want to change the sorting logic, then I need to change the code. That's the issue with comparable. So that's the drawback with the comparable. But with the comparator, it's not the thing, because comparator takes different class. Comparator takes a different class. We need to create comparator with a different class. So for default sorting order due to comparable, but for customized sorting we can use the comparator. The classes whose objects are sorted do not implement this interface. Some third-party class can also implement this interface. In our example in the last session, in the comparator, the student object we need to sort, right? So student is not implementing anything. but with the comparable, employee is implementing the comparable. So that's what it means over here, that comparator does not force its class that needs to be sorted to implement this interface. Some third party class can do also implement this interface. What do we mean by third party class? This student name comparator that we have created, student roll number comparator that we have created in the last session. So third party class can also implement this interface. So that's the thing with the comparator. So today we have, and then now the difference between these two, right? So obviously the better choice for every time whenever you want to implement it will always be the comparator. The reason is we are not forcing our class to implement anything. You will never see anyone using comparable. Very rare chance it is. You will see that there will someone using the comparable. Otherwise, you will always see a class to implement comparator, because we don't need to implement that class, right? A student class, because this student will be an entity, because it will be holding a lot of data already with a lot of annotations already. Then we don't want to implement more things, right? Don't want to complicate things also. And then there's another thing, different use case require different way to write code over here. So we don't want any other code to be here. And also in real life scenarios, we never want to sort things in a single order. So every time you will see in the production environment, you will use comparator instead of comparable. All right, I'm audible?
Yeah.
All right, let's move to set now. So we already completed the list. Now we'll move to set. So how to create set basics, we'll cover the basics. All right, and see, with list there were few points, right? That was common for all the list interfaces, right? And which were, in list, do we preserve the insertion order or not? In list interface, do we preserve the insertion order? The answer is yes. We preserve the insertion order in list. All right, I'm audible? See, what does it mean by preserving insertion order? That, wait, let me show it again. Okay, list basic implementation. So over here, if I added 1 for the very first time, then true, then null, right? So if in the data structure itself, it will be 1, true and null, right? This is called insertion order preservation. If you send data in the in the array, like in the array, if you insert the data in the array index 0, it will be preserved in the array index 0. If you want to fetch it, you will get it from that index only, right? It's not like you will send the data in, you will get the data in some other order. So it's called preservation of insertion order. All right, there was another thing that was allowed in list, that was duplicates, right? Duplicates was also allowed. Null insertion was also allowed, right? Heterogeneous data only not allowed in tree. Whenever you will see tree something, tree map, tree set, only there it's not allowed, because it provides auto sorting. Clear till now?
Yeah.
All right, so with list, with set, sorry, not with set interface, we'll have different classes like we have with the list, array list, linked list. With the set, we will have hash set. This is the set interface. Same thing will happen, right? Collection interface, over here it's set, right? Earlier it was collection interface, and then here was list, right? And over here you will see we have a hash set class, all right? And then linked hash set class, and then tree set class. 3 classes, 3 implementation classes we have, all right? This sorted set and navigable set, these are interfaces. The implementation class are only 3: hash set, linked hash set, and tree set. All right, so one thing you need to know, whenever the hash, what's the what's the main use case of set? What's the difference between list interface and set interface? Main difference between list and set. All right, you never done anything with the Java, oh, cool. So the main difference between the list and set is set don't allow duplicate. All right, it's like a discrete math set. Sets don't allow duplicate. So that's the priority item in the set. that if you have an interview question, that remove the duplicates from a list, then you can directly just convert it into the set. We don't want this thing in an interview question for anyone to do, but if you have the duplicates in the list, then you can just simply use the set and remove those things. Set don't allow the duplicates. That's how we can do this thing. But and okay, let's come to the has set common items. Okay, there are no common items. Cool. Okay, one needs to be common. I've not written out it over here, but one item is common, that it supports, it does not support, it does not preserve in such. Oh, no. For all common is the simple that it don't allow the duplicates. That's the only thing that we have in common in all these, in all the child classes of the set, that we don't support duplicate values. We only will have single values, right? Now we will go and check each one of them. There are 3 classes, and set are easy to go because it does not support a lot of stuffs, so it's easy. Hash map will take some time. So 929, all right. Okay, we already, okay, no, basics we have right now here. All right, cool. So we are going to create a set. So set interface, right? And I want it of integer. Now set will also have the same, all collection have the same thing, that they can allow homogeneous data, heterogeneous data, right? I'm not doing this right now. You can play it in your free time. So set, and let's say okay, values only, right? New has set. All right, this is the first implementation class that we are using, has set. All right, so what are the things with the has set, right? So let's value dot add, let's add one. Values dot add, again we'll try to add one. All right, then values that dot add 2, and then values dot add 3. All right, and let's do 4 and 5 also. 4 and 5. So over here, if I try to print the set and the values, all right, so you will see, because set does not support duplicate values, you will not see one twice, you will see only one once. And another thing with the set is it does not support insertion order. So with the set there is one thing, does not support, we are talking about all the sets right now, does not support duplicates, because that's the USP of the set. Next thing is insertion order is not preserved. We can write it anyway, right? It can be at the top. Insertion order is not preserved. All right, so if I run this now, you will see, okay, it, for this particular case we have preserved the insertion order 1 2 3 4 5 we are getting, right? But insertion order is not usually preserved. What we can do is I can just cut paste over here and then run it again. See, now I added 4 and 5 first, right? Visible? I'm audible?
Yeah.
And it's provide the value 1 2 3 4 5. Don't think that it has been sorted, right? It's just the way it has provided. We'll see how it do the things internally later, not now. So these things we have seen, right? It does not support the duplicates, it does not support the insertion order, it's not preserved, right? So that's the thing with the has set. Heterogeneous data allowed, we are not going to do this again. Duplicates are not allowed, right? If we try to insert the duplicate values, then we won't get any compilation error. I have tried to add again, right? 1 1 again, but I haven't get any compilation error. What it usually do, it simply returns false over here, because it finds the value already there, then it returns the false. But nobody takes that value, usually never use. Null insertion, okay, yes, null insertion, right? What about null insertion? Null insertion is possible, but the thing is, if I add the, okay, I mentioned null over here, right? What will happen if I run this code? Anyone wants to answer this thing? Okay, this is not an interview question because this is very basic. Because integer class can hold null, right? Then that's why there will be no issues. Sometimes people get confused that, okay, if there is an integer, I have marked that this set will hold only integer, then it won't hold null, but it will hold null because this is an object, and object value can be null. Don't treat it as a primitive data type that its value cannot be null, right? So now, but the thing is, if I again add null, because duplicates are not allowed, so you will have null only once. All right, so that's the thing that's mentioned over here. Null insertion is possible, but if we insert more than one, so twice insertion of null is not possible because it don't support it. And then underlying data structure is hash table. We will see later on what it do completely when we cover the map. Then insertion order is not preserved. It is based on the hash code. Again, we will see in the map part. Methods also non-synchronized, and it supports only one cursor. All right, cool. We already done this. Let's copy paste this thing, and let's go to the traversing of set. And in traversing of set traversing runner. So when we are traversing the set, we need to know few things, and we need to remove these two things right now. First, okay, if I run this, we will directly see it's not in the ordered format, right? And the next thing is how many ways we have used to traverse in list. First, normal for loop, right? Or legacy for loop, and then for each loop, right? Introduced in 1.5, then iterator, right? Then list iterator, and then streams, right? In 5 ways we have traversed, right? I'm audible?
Yeah.
So the legacy loop does not work with set. A reason we'll see later on, because it use hash map internally. We'll see all those things later, and hash map internally use hash table, so those things we'll see. And one more thing, that our list, let's say array and list. All right, list interface implements the random access. I don't know whether it needs to be known or not. This allows to get the value. This allows this getI thing is provided by random access class interface, and this is a marker interface. We have covered the marker interface, right? We just need to implement it. There is no method inside it, but this marker interface provides your class capabilities to do few things like the serializable and clonable. So this is a marker interface. This interface allows list to use the getI method, right? Over here it's present already. So our sets don't implement this thing, right? Our sets don't implement. Okay, can you please go at the top? I need to see the class name. Yes, has set, and you will see no random access, right? So our class, we cannot use I, right, to fetch the values. And it will become more clear when we cover the map. Then we'll know what it internally using. Next thing is for each loop, right? Yes, we can use the for each loop. So okay, this is out. Okay, why it is considering it as a comment? All right, so traversing using the for each loop. All right, so for, and I will put the values, that is the collection, and it is an integer collection, right? So it will return the integer, and value, I'm putting the name at values will provide the value, right? And I'll just simply print the values over here, and value and plus comment this thing, right? So, and later on Evernox again this out. So if I run this now, so set has printed 1 2 3 4 5, and my for each loop also printed 1 2 3 4 5, right? And it's not in the insertion order, right? Insertion order is not preserved. I have put 4 and 5 first. So this is one way we can use with the set is for each loop. Now the iterator part, right? Can we use the iterator? Values dot, what I mentioned, the data structure will provide you the iterator, right? So we'll try. Do we have the iterator class? Yes, we have the iterator class. So same thing will happen, right? Iterator will remain same. Integer iterator itr. And I've seen in the last, I've been using Java for a decade, I've never seen anyone using other name than ITR for the iterator. Everywhere you'll see it will be ITR. Everywhere it will be ITR. Okay. So the thing will be same like it was with the set. Okay. If, oh my bad, while iterator dot has next, then sys out and simply print iterator dot next value and then plus and then this thing and then sys out just to make sure. And let's write one more thing over here, sys out traversing using iterator. All right, let's run this again. Traversing user iterator 1 2 3 4 5, right? Let's just put a little space over here just to make sure the data is same. Then list iterator, right? A list iterator is shouting that I am a list iterator, not a set iterator, right? So list iterator work with list only, right? So we cannot use list iterator with any other. We cannot use list iterator with map also. Now the streams. All right, obviously we can use the streams also. Traversing using streams, and again it will be simple values dot, we need to start the stream. So now we have the stream, then for each value of this thing I want to use the system.out.println, and I will remove the ln and I will use the value and plus and simple comma. All right, let's run this again. Traversing using streams, right? So we have covered. Now for set, for list interface we had 5 ways to traverse. For set interface we have only 3 ways to traverse, right? Iterator, for each loop and streams. Cool. List iterator don't work with it. It's obviously it's a list iterator, so it will work with list only, and we cannot use normal legacy for loop. The reason is it does not implement the random interface, so we cannot use it. Internally you will see why. I mean it make no sense for it to implement the random interface also, because internally we use hash table and the data structure we use it's hash map. And why to believe me? So we can directly go inside this and you will see in the constructor of hash set we are using hash map. We will see about its internal implementation later when we complete the map. All right, visible, clear till now? Hello?
Yeah.
All right, now the thing is sorting is left, right? Traversing is done, now the sorting. All right, so for sort, right, is sorting. Okay, let's write the set sorting. Oh no, let's name the class. Is sorting possible? Runner. All right, so see, for sorting, right, for sorting what are the basic necessities? I mean, I want you to answer, right? I mean, you can answer. This question is very simple. You can answer. When can we sort data in a set? Okay, just give me 1 second and you can try to answer. Anyone? Oh shit, 2%. Hello, Dikshita? Okay, hello.
Homogeneous data. I mean, which should be comparable to each other.
Okay, right. Homogeneous data we want, and we want more than one data to sort, more than one element to sort. Any other requirement? We need, I mean, that's why the people with the good knowledge of data structures and algos are preferred. The reason is you also want a data structure which can hold the insertion order. Like for example, let me show it to you. If this is your set, right, and if you insert 1, right, and you have 5 value, you don't know that set will not preserve your insertion order, right? So if you insert first 1, then it will put here. It will insert 2, then it will put here 3, then it will put it over here 3, right? So if you try to sort it also, right, if you are traversing, you will see, okay, 2 is less than 1, right? So if you try to put the value 1 over here again, I mean, you don't have anything, right? We don't have any access to make sure that it is putting the value in with the very first place. So for sorting, we require data structure which preserves the insertion order. If the insertion order is not preserved, then we cannot sort that thing. Am I audible? If this thing is not making sense to you, you can go ahead and read about it. This is the thing. So set cannot be sorted, right? Again, one more thing, don't take my word for it, you can go and read about this thing, and it's way too obvious also if you'll try to do this. Think about it. Another thing is, we were using collection.sort method, right? Collection.sort method, you will see the collection.sort method is working with list only, right? Then sorted map, and then the reason is something else for this, and then over here you will see there is no set, right? And the sorted map, it's used because we have the structures which can hold the values, right? So for example, we'll have the linked hash map we have. So, and linked hash set also, if you want to preserve the insertion order. So the thing is, if you want to sort things, then we cannot do it with the set, right? So sorting is not possible with the set. So sorting is completed. Now the thing is, again with the sort, there are two more classes that we need to see. One is linked hash set and another one is tree set. So now let's come back to time. Okay, 47, we are going at good pace. So set, and it was tree set. Okay, no, it is hash map. Oh sorry, hash set runner. It was a runner, hash set runner, basic runner. And now we want linked hash set runner. All right, so I'm not going to do anything. I'll just take the same code, right? Copy paste it over here, right? So the thing is, insertion order will not be preserved, right? In this code, I have put 4 first, 5 first, and then duplicate will not be supported over here, right? But insertion order is not preserved with set. But okay, why? Okay, all right, no worries. हेलो हाँ ओके, एक मिनट रुकना.
Yeah.
All right, so this thing is clear, right? If we want no duplicates in our group or in a collection, then we should go for hash set. But if we have the requirement to preserve the insertion order also, because hash set will not preserve the insertion order, then we'll go with linked hash set, right? So, and now the thing is, if you want that, okay, my insertion order is preserved, now can I sort it? So you'll not get anything to sort with the linked hash set because it's way too costly to sort on it. So you'll get another data structure that is tree set. Oh sorry, another collection that is tree set. So if you want to sort things up, then you can use the tree set, right? And then a question arises. This is not related to the interview question. What will happen when you doing things in the production, writing code for the company, and if you have a set, someone is returning you a set, and you want to sort the data in the set, then how can you do it? The thing is, you don't want duplicates. That's why you are using set, right? So now your set sets don't hold any duplicate values. So you will convert your set to list first, and then you sort your list and then work with it. This is how we do things in the production. All right. And if you have anything, okay, let me just show you. For okay, temp, I'll delete this class in a while. So like for example, we have a set. Okay, let me show you how we convert a list into set. Let's example from a, let's take a list, and let's say that in the list we have integer list, we have an integer list. I have some data, time 10 for, okay. In integer list we have some data, for example, okay, values, we can take it, right? And values and duplicate values is there, and new array list, and I can duplicate values dot add 1, and I'll add 1 twice, and then duplicate values dot add 2, and then 3. All right, okay, 3. Cool, visible. So if we print, okay, my bad, if we print duplicate values, so it will be this, right? What if I want to remove the duplicate values? So set itself says that I'm not duplicate. All right, so integer set, and then new has set, and in its constructor I will put the duplicate values. All right, visible. So now I'll just print the set, so the set will not have duplicate values, right? So but the thing is, if I run the code now, we'll see the duplicate values will have 1 1 2 3, and the set has 1 2 3 only, right? Okay, it's in the insertion. Okay, wait, okay, so let's remove the, okay, it will by default sort things, so 3 and 1, and I'm running it. Okay, I wanted it to give me some other values, but it must be using, okay, wait, let's just use 101 and 202 and 308, again 101. That's it now. All right, cool, visible. Now insertion order is 3 1 and 2. Okay, again it's kind of preserved, but it's not in the sorted form, right? Am I audible?
Yeah.
So okay, but okay, yeah, great, it's not in the sorted form. But if I want to sort it now, so what I will do, I'll again make it a list of integer. Again it will be unsorted list equals to new array list, and I'll put the set over here, and then I'll use, okay, so now I have a unsorted list. Now I have an unsorted list, and with this unsorted list I'll just simply do collection dot sort and unsorted list, and then simply again unsorted list sorted. Okay, sorted, we can make it sorted. Now the list is sorted, right? So unsorted list, if I run now, I had the duplicate value over here, so I convert it into set, so remove the duplicate values. But now it's not sorted, I cannot sort on set, so I convert it into list. Now then I sort the list. This is how we do things. All right, I have done all these things in a single method, but the thing is, one method would be giving you some X data that you are fetching it from the database, then it will process and it will remove something, then you will get some other data. So everything will be happening in different methods. That's how this thing you will do in the production environment. All right, so I have deleted this class, you will not see it in your, in the code base now. Okay, oh, all right, we have completed this thing. Let's move to the map. Okay, so map, like list, also have 3 classes, and it has the same name also: hash map, linked hash map, and tree map. It will have exactly same implementation, same thing that we have seen in the set, because set is using map itself internally. So now if we go in the map, okay, let me check my battery. Okay, 24, great. So in the map, all right, so let's see hash map. Okay, map is a big deal, so let's make thing. Okay, map hash map linked hash. Okay, my bad. Linked hash map, and the tree map will also have the same implementation. Tree map, and it will have into questions. All right, basics again. So what's the difference in the map? Like the set, the list is, it will preserve the insertion order, it will allow the null insertion also, and it allow duplicates as well. Now the set does not preserve the insertion order does not allow duplicates, but some child implementations of it, like the linked asset, preserve insertion order, and tree set do the sorting on its own by default, right? But what's the difference with the map? Map is the data structures which have the key value pair. So hash map basics. What does it mean by key value pair? Hash map basics. So for example, till now what we were doing list, and we were saying that okay, the list will be of integer, it's called generic, and list equals to new array list, right? So a single linear data structure we will be using that, okay, there can be 10 integers, right? Let's take a string. So we can add few names, right? Like for example, list.add Delhi and list.add Beijing, right? And I can just print this thing, list. So this is a linear data structure which have only one data associated with it, Beijing and Delhi. But with map is different data structure. It has key and values. So for key it can be string. For example, if I want to save the country name along with its capital, then this data structure we cannot use, right? I want some different data structures where one can be key and other can be its value, and the map is a key value structure, data structure that we get. So we can say city, country, city map, where key will be country and map. Okay, you can see first I need to put the key and then the value. Key I'll say India and value will be Delhi, right? So that's how we do it in the map key value pair. Over here I can say China, it can be Beijing. Over here we can say USA, and it will be Washington DC. Okay, Washington DC. All right, cool. So now the thing is, we don't want city over here. If I print this, okay, country city map, you will see it over here like this: key USA and Washington DC, again key, again value, again key, again value. Now the thing is, why the data is in this manner, right? Because it also does not support insertion order. If it's supporting the insertion order, then India should have been at the top, right? So it does not support insertion order. So map also does not support the insertion order. Cool. So if it does not support the insertion order, one thing is clear: we cannot do the sorting over it, right? The collection.sort methods with comparable and comparator, we are not going to work over here, right? I'm audible? Because this data section does not preserve the insertion order. So now another things, let's see. So same thing will happen, right? But whatever was happening with the set will happen with the hash map or map interface, because set internally use map. And okay, we can hash set. Let me also show you it again. Whenever I'll do hash set has a constructor. Okay, my bad. So this is the hash set constructor, right? New hash set. In hash set constructor, you will see hash map visible. So if you are creating a hash set, you are using a hash map. So in the coding platforms like LeetCode and some other platforms, if you are using hash set, then you are creating two objects, because hash map object is directly being created behind the scenes. So you can improve your time complexity a little bit more if you are using hash map directly instead of hash set. So just a trivia. Okay, and we'll see how the complete this hash map works, and then how set uses the map. I mean, why set uses hash map internally. We'll also see that in a while. So one thing that we have seen, that duplicates are allowed or not allowed? Are not allowed, obviously, because it's set internally uses hash map. So if set does not allow something, that it needs to be the same as the hash map, because hash map also does not support it. Same thing will be happen if insertion order is not preserved. Null is allowed.
Uh, I had a doubt.
Yeah, go ahead.
Duplicate keys in the sense the first value, right? Not the second value. So the second value could be duplicated.
Yes, yes.
Okay.
We will come over there. Okay.
Okay.
Okay, this point. Okay, yes. Duplicates keys are not allowed, but values can be duplicated. See, the thing is, you will get it in a while because when we see the hash code implementation, then you will get it on your own. So the main important stuff was this only. Now, okay, the same thing. Let me just go through these 8 points and then we'll work with the hash map for a while. So this not required. This is same for almost all data structures except from trees. Then it uses hash table under the hood, like the array list use the arrays, linked list use the linked list, stack use the stack. Similarly, hash map uses the hash table, and hash set use the hash map, which uses hash table. So hash set also use or the set also use the hash table. So now coming back to this, duplicates are not allowed. Keys duplicate not allowed. Maps values are allowed. Why this happens? Cause of hash code. Insertion order is not preserved. The reason is hash code. We haven't even talked about this in the set also. We'll talk now after a while. So null, again the same with the hash set or the set key set. Null is allowed only for once, but for key bit values we can do it for a number of times, right? Because the same thing will happen for point number 4 derives the second part of the point number 6, right? Because if duplicate values are allowed, then null will also be allowed, right? Because null is allowed, and for keys values duplicates are also allowed. So I can put n number of null values for value, right? But for key it will be only one, because duplicates is not allowed. All right, is it clear? I'm audible?
Yeah.
All right, we'll
Yeah.
see now these things, right? So again, now the thing is, in India, if I do India Delhi again, right? I'm putting India Delhi again. So you will see duplicates not allowed. Duplicate keys not allowed. Right? So if I run this, India and Delhi will not be twice, right? You'll see India is only once, right? Key. But if I do one thing, that instead of China Beijing, if I do China Delhi also, okay, let's write some other country. Let's put South Africa, and put its country as city as Delhi also capital, right? Then you will see India Delhi and South Africa also Delhi, right? So values can be duplicate. Visible?
Okay. Okay. Yeah.
Values can be duplicate. And now one more thing. If I update India, if I do this India to New Delhi, what will happen now if I run this?
Error because keys cannot be duplicated.
No key, it will update the value of the key. So now India will have New Delhi as its capital, right? It will update the value because key was also there, right? India and Delhi was there. Over here also India was there, so it updated the value to New Delhi, but we haven't seen that value has changed because we were using the same value, right, for the same key. Over here we have used the same key but changed the value, so it will simply go and update the value. All right.
Okay. So the last in the last input will be updated.
Yes.
Okay.
All right. So this is the thing with this map and key value pairs. Now we will go internally a little bit, right? Because we want to traverse. So let's go and traverse things up. And I'll just copy paste this thing and we'll go and do the traversing. We know that we cannot sort it, right? So we'll directly do the traversing. All right. So hash set. Okay, map. We are doing map traversing runner. So we have this example already. Let me run it again. Now then we'll know that what data we have. Key value, right? So we have 4 countries, with two country having duplicate values, right? Till here it is clear, right?
Yeah.
How many ways we have traversed earlier? For each, okay, for loop, legacy for loop, right? And then for each loop, right? Am I audible? And then
Yeah.
iterator, and then list iterator. I'm just putting it here, right? But obviously it will be used with the list. And then it was streams, right? And this is the way we have done the things till now, right? Obviously we cannot use the for each loop because it's not implementing the random access. So hash map, instead of every map, don't implement the random access. You can see over here implements map, clonable and serializable, right? Clonable and serializable, and if we go inside the map, also nothing else is here, right? So coming back, so we know that we cannot use it, does not implement random access. Now the for each loop, can we use the for each loop, right? Yes, we can, but now the thing is, it's not a linear data structure, right? It's a key value pair, right? I'm audible?
Yeah.
It's not a normal data structure that we can traverse directly. Now one thing is, can I get all the keys? Is it possible in the for each loop? For each loop using keys only. All right, so yes, it's possible. How can I do it? What is the okay, so how can we get the keys, right? I need the name of the map and then key set. All right, so now you'll know that it says set, right? So it will return set. And why it will return set? Because key cannot be duplicated, right? That's why it's returning set. So over here the key is of string, right? And it's of country. So I can just simply do this and sys out and do right country, right? And just put com over here and remove this thing. All right, so if I run the code now, for each loop using keys only, and this is data, USA, South Africa, China, India, right? And our map is this, visible? I have all the keys now, visible?
Yeah.
So now the thing is, what about the values? So same thing I'm going to do. I'm just going to do copy paste and use the values. Now the values part is little tricky because values can be duplicate, right? Values can be duplicate. So I can just simply print. Okay, now let's change the variable name to city, capital. It's capital, and just replace capital over here. And then if I run this now, okay, one sys out is required before. And now if I run this now, you will see for each loop keys only, country names, right? For each loop values only, you will get Washington DC, Delhi, Beijing and New Delhi, visible? Am I audible?
Yeah.
Cool. Now the thing is, but if I want the complete structure, I want key value pair as well, right? Now we need to know one thing before that the map we are using over here, how this thing is stored, right? How this thing is stored. This thing is stored in an object which is called entry. Let's go in the hash map and let's try to find entry. All right, so where is entry? Okay, let's go to the entry iterator. We'll see this. So map.entry, right? Okay, it's interface over here. Cool, no worries. But you will see in the map class we have an interface entry, visible? Entry have the key value pairs, k is key and v for value. All right, so entry is the class that is stored in map. Internally it's an entry class where we get the data. So what we are seeing over here, this key and value, in a common part it's an entry, and the entry has key and a value. Entry has a key and a value. All right, so and it's a internal, it's a class, nested class of map interface, right? So it's a nested interface, not, we cannot call it class, but the implementation of those provides the implementation classes provides its implementation entry map.entry and UK. Okay, cool. Okay, it's using node. Okay, so all right, it's going to take some time. You can just go inside it and you can check in this. So the thing is, it has, the map has key value pair, and the in the structure that they use is called entry. All right, so if I want to traverse the collection directly like we were doing with list and set, then instead of single value, now I need to use entry, and entry will have key and value pairs, right? So I need to mention that key and value both will be string, and over here I will say it entry. Is this code clear? We have seen the map class entry, right? Nested class. So this is how we call the nested class, map.entry, and string and entry object, right? Now how will we get the key and values? So over here, let me write the ln also. So entry dot get key, and for the value we can do just entry and dot get value. And over here, but the thing is, again, we cannot use directly the country map. We need to call a set, entry set. The entry set will return the set of entry, key and value. All right, if we run this now, we will see the value: USA Washington, South Africa Delhi, China Beijing, and India and New Delhi. Visible?
Yeah.
So map is a different data structure, it's not linear. So if you want to traverse it, we have, using the for each loop, we have three ways to traverse. One, we can traverse only keys, one we can traverse only values, and one we can traverse the entire entry, because it's called an entry. One input in it in the hash map is called an entry. The pair of key value is called an entry. All right, it's only for the Java. It's not like entry is a common keyword for everyone, for every language. It's just for the Java. All right, so we have done this thing with it. Now the iterator, we know the iterator will be, if exists, then iterator will be provided by the collection, right? So do we have iterator over here? Do we have the iterator? This is the collection, right? Visible? I'm audible?
Yeah.
So do we
Yeah.
have the iterator? ITR, not able to find, right? And let me show you first. Array list. All right, if we go inside the array list, so we can find the iterator, list iterator also, but iterator also will find. Okay, iterator, right? This is the class, this is the method iterator, right? It's returning the iterator object. Visible? So same with the bad hash set. If I'll do, and if I'll try to find the iterator, this is the method that's returning the iterator, right? And now if I'll do the hash map and go inside it and try to find the iterator, then I have it over here. Visible?
Yeah.
But the thing is, why it was not visible in the ID when I was doing the collection city map, then iterator not coming, right? Visible?
Yeah.
And over here, if I'll do iterator, okay, my bad, iterator, then we have the iterator over here. Why it's entry here? I want iterator. So hash iterator is here, and with the hash iterator, okay, well, it's not just iterator, this is the iterator, right? So where it's okay, when I'm trying to find the iterator, where it's going, okay, this iterators, okay, and new iterator, it's not iterator, this is the iterator. Visible? Am I audible?
Yeah, yeah.
So iterator is there, right? But iterator is at which level? If I'll do the entry set, then I will get the iterator. All right. It's not at the collection level, it at the entry set level. Got it? Difference? I'm audible?
Okay.
See,
Yeah.
I mean, you must, okay, cool. Let's see over here as well, right? Have we used directly map anywhere? We are using key set, right? We are not traversing on map, we are traversing on set, right? In the map interface. Visible?
Yeah.
In the values also we are using collection.
Yeah.
Collection is an interface which is implemented by everyone. So it can be list or it can be set. Both implement this collection, right? Map does not implement it. So over here you can convert the result of this into anything. Whether you want it as a list or collection, you can convert it into this. That's why collection is being used. The next thing is entry, right? Entry also we have used set, right? We have never directly used map, right? On traversing.
Yeah.
So over here as well, we will never get iterator directly. The entry set will have the iterator. So if I want to traverse it, I will get the iterator from here. All right. And I'm just traversing over here. Okay, itr equals to this thing, and then while same thing will happen, right? itr.has next simply is out. Okay, let me just copy paste one line, these two lines over here, and let's just okay, iterator and loop using entry, and the same thing. Let me just copy paste the same thing over here. So only thing that will change, okay, and what I can do the simply map dot entry and string and entry and itr.has next, right? It's giving error. Can you point out why? Because I'm using hash next. Next is the one that returns the value. Now again it's showing an error. If I convert the response into the map.entry, now it's fine, right? I'm audible?
Yeah.
We never had to do it because we were directly converting the values, right? So that was the reason. But over here we need to take two values, so that's why I need the random middle variable. So if we run this iterator using loop, right? Okay, loop, let me remove the loop. Using iterator, traversing using iterator, using iterator on entry set. All right, so you will see here traversing using iterator on entry set, and this is the data, and you can traverse it on key set and on your own, right? If you want the key set, what we'll do, country versus this and key set and then iterator, right? Visible? So if you want to traverse it, you cannot traverse directly on the map. You need to convert the map into a list, you can, or a collection or a set. You can convert the keys into the key set, you can convert the values into a list or set according to your need, and another thing is you can get the entry object as well, but you will get it as a set, and then you will loop it. So we don't directly loop the map, we use set to loop it, right? Got the point? Again, now the list iterator, okay, does not work with only list. Work with only list. Now the streams, right? See, over here we have traverse while in iterator or while in the for each loop, we have traversed the map using the set only, right? So in the streams also the same thing will happen, right? Country city map and key set, then stream, right? First we convert it into set and then we are streaming, right? Then it will be the same, right? Okay, key set we have taken, so it will be country, and I'll just print the country and put a simple this comma over here and copy paste, traversing using stream on key set. All right, so over here you will see if I run this now, same thing, it's like traversing on a set, traversing using stream on key set, right? These are the countries of the key set, right? Visible? Let me just remove the line so that it can be visible in a single line. Okay, visible? Traversing using stream on key set, and these are the 4 countries: USA, China. Let me put a space as well. Clear?
Yeah.
Now the same thing I'll do, but with on values. All right, so instead of key set I will add need values, right? And value will be capital, so I'll just change the capital, and if I run it, traversing using stream on values, Washington DC, Delhi, Beijing and New Delhi, right? And the same thing I can do because I'm just traversing the set. So on key set, so what I can do over here, instead of this I can say that okay, let me just remove this, let's start again, country map dot, okay, my bad, entry set, and on the set I'll open the stream, and for each entry I want to print out entry dot get key plus same thing that I did above, plus entry dot get value. All right, and if I run this, okay, if I run this now, this was traversing using on key set all the countries, traversing using values, then I'll get all the capitals. Now traversing on the streams, then I'll get Washington DC, South Africa, and these all things. Visual?
Yeah.
All right, see, you need to do it. We are going in a fast pace because otherwise I used to take set on only a single day. Now we are doing map also in a single day, so we are consolidating a lot of things, and the collections is like something that you need to work on the daily basis, right? And we do every day we work with the collections. There will be not a single day if you're writing code and you're not dealing with the collections, so you will get it on your own. All right, so we have done with the traversing, right? So now we know how to traverse the map. We know we cannot sort it, right? Because for traversing we need to convert it into list or set, and we know that the set cannot be sorted. So if we want to sort, then we have only single option, convert it into list, or we have 2 more classes. Okay, 1038, cool, no worries. We have 2 more classes, and okay, let's go to those classes. Collections map, let's go to linked hash map. Okay, linked hash map runner, and we'll go to this basic, we'll copy paste it, and we'll just paste it over here. And if we run it, we know that insertion order will not be preserved, right? USA, DC, South Africa, China, Beijing, right? So China should be at the top, right? Because C is there, right? Then it should be I, then it should be S, then it should be U, right? Okay, wait. Okay, I've just told you about the sorted thing. Insertion order should be India should be first, then China, then USA. ICUS, right? ICUS should be the thing. If I convert it into linked hash map and run it, India ICUS, insertion order is preserved, right? support insertion order. All right, I'm audible?
Yeah.
Same thing that has happened with the set. And now if I want the sorted item, right, tree has set runner. So same thing, if we just copy paste things up, right now insertion order is preserved but not sorted, right? But if I'll just convert with the tree hash map, my bad, tree map. So now if I run it in the sorted order, and the sorting order will be on the keys, right, not on the values. So the key will be, if we try to sort this, China should be at the top, then India, then USA, and then the South Africa, right? If you run the code, China, India, South Africa, and USA. Visual? Hello?
Yeah.
Again, the same thing that we have done with the set. If I try to add null over here, what will happen? If I run it, there will be an error, right? Because it's trying to do auto sorting, and in auto sorting, it cannot compare null with the value, right? I'm audible? One very bad question is they provide the null but in the column, I mean double quotes, so it's a string, right? So null as a string will work, right? Null over here, null as a string will work because as a string null, like, we can compare, but not null. Null as a string is different and null is different. If you try to run null, so it will throw an exception, same as the hash set that we have done. So not allowed, null not allowed, null values not allowed. All right, as key. What about if I add null value? All right, if I add some random country, let's take random, and then put the null, then what will happen? Will it throw the error? The answer is no. Random null, right? In the values we can have null. Null values are allowed. All right, clear?
Yeah.
All right, cool, great. So now the thing is, now we have to dive deep into this thing, that why, how hash map internally works, right? I just hope I have some figures and diagram over here. Okay, object class 2 methods was left, right? See, most important entry question is hash code was left, right? So most important entry question, it can be asked in different manner, right? What's the contract between hash map and hash code and equals method? The question can be hash code and equal method contract. All right, I'm audible? Or they can say how hash map knows, how hash map detect, I mean set internally use hash map, right? So we know that hash map detects whether the key is duplicate or not, right? I'm audible?
Yeah.
So hash map detects, right, whether the key is duplicate or not. So how does hash map detects whether a key is duplicate? That's the question. And just give me 1 minute. Shit. Okay, I think, okay, it's the recording is there is a loss of the recording for a few minutes. Okay, we'll see it. I will try it again. Okay, so okay, where were we? Okay, collections. And in collection, okay, contract between hash code. All right, cool. So this thing is the most important item. All right, please be aware, be mindful in this thing. Let's keep it into the interview question part. Most important thing, right? You will get it. If someone wants to ask the question from the collection, you will get this question for sure. Interview question, and it can be asked in different manner. How, I mean, how the get works. Okay, I haven't shown you one thing, that if we are keeping the value in the map, right, the reason we put the value in the map is we have the key later on, but we want the value. For example, if this is the map that I had and have a key, like for example, I just need to print out country.citymap.get, and if I put over here India, is my screen visible?
Yeah.
So if I use this, then let me just remove this thing, not required. All right, if I use this, then I will get the value New Delhi. All right, I have passed the value India as a key. I'll pass the key, I'll get the value. This is the thing that we get from the collection. And now one thing with this is, this operation is O1, log O1, right? This is the best case time complexity that can happen in the entire computer science. So to get the item in the log O1 operation, there is no other data structures that can do it apart from the hash. Using hashing, this internal data structure is hash table over here, right? So that's the only way we can do it. And it's not complete, it's not every time O1, sometimes it can be log n. We will see it in the later session, later part. So for this reason we use it, right? Get. So the question is how the get internally works, or how the put internally works. What happen if I do the India dot put? What happens if I do the India dot get? All right. So now we'll go here, and okay, what was it? All right, no worries. So okay, okay, and let's take this example only. We have India, China, this thing, right? Or let's take some other example. Okay, let's take an example of something else. Let's say that we are doing map, and we are doing integer right now, integer, and the value can be string, right? We have no issue with the value, and we can say it country name, country ID and name, country ID and name, right? So this will be country ID, and this will be country ID, and this will be country name. All right, equals to new hash map, right? So one thing that you will know with this any data structure, any collection, if you'll see, whenever, okay, right now we are using normal tree map, hash map, right? So over here, if I write 0, it's not taking any value, right? Tree map visible? I'm audible?
Yeah.
So if I'll do the same thing with linked hash map, if I try to pass something, it is taking with the value of, there is a constructor with initial capacity visible, visible.
Yeah.
So the initial capacity is how much value you want by default. This is the initial capacity. Right now I'm passing 0. If you don't pass 0, it will have some initial capacity, and it can change with the version of the Java, but by default for the map is 16. It will get you 16 places, right? And buckets will go there, how it happens. Now the thing is, and at a certain time it will grow also. The internal data structure for entire collection is global. If you try to fill it at a certain level, it will automatically increase its size. For a collection like linked list, there is no issue, because they don't need to to grow indefinitely, because linked list is a structure that can grow, right? It don't need contiguous allocation, but others grow as soon as a certain threshold is met. All right, and then being said to, so what happens when we do this? We get 16 buckets. Okay, let me just show you over here. If I mention it somewhere, okay, yes. Okay, there must be some diagram that I have put here. Contract, no, hash code, are we in a loop? Yes, we are in a loop. Yes, all right. But how it is possible? How it is possible? Okay, list interface, and this is iterator, list iterator. Let's go to the map first. I'm showing you in the notes, right? In the map interface now. It should be somewhere. It should be somewhere. All right, if it's not here, okay, end it. All right, cool. Okay, no worries. We can do it without the diagram and all. Okay, no diagrams and nothing. Cool, no worries. So see, the thing is, if I use the default version of it, we get 16 buckets. 1 2 3 4 5 6 7 8 9 10 11. Okay, my bad. And 12, 13, 14, 15 and 16. Okay, so we get this 16 buckets, right, by default. Now if I come and I'll do country.id name.put, all right, over here 1, and I love my India, all right, 26 January also. So this thing will create this, all right. Now if I do this, I have 16 buckets. Visible? Am I audible? Hello?
Yeah.
All right. Okay. So I have 16 buckets now, right?
Yeah,
So
yes.
if I am using put right now, this is the internal implementation of put method, right? We'll go to the get also. So in the first thing, I've used put. So in put, what will happen? Now this question can be asked in 3 different manners, right? One thing is contract between hash code and equals method. Another thing is how the put and get method works in a hash map. And the third is write a code for user defined objects like a student or the employee, and make sure that there is no duplicate students there, right? Get the point? You need to just create 10 students for 3 students and try to insert duplicate students in the set or map, and then make sure that there is no duplicate students in your set. That's the question or the requirement. So now the thing is how it works. This is the answer for all these 3 questions that we are doing right now. So how it internally work in this, right? For example, the hash code method, right? And where is the hash code method? Hash code method is available in every object, right? Extends object. Why hash code is in every object? Because it's in the object class hash code. Visible? It's in the object class over here. Visible? We are in the object class. So hash code is in every class, right? So to find the bucket, in which bucket it will be present, what will happen? It will use the hash code method to select the bucket, and these all bucket will have numbering, right? This is bucket number 0, this is bucket number 1, this is bucket number, oh my bad, this is bucket number 2, this is bucket number 3, bucket number 4, bucket number 5, bucket number 6, bucket number 7, bucket number 8, bucket number 9, bucket number 10, bucket number 11, and bucket number 12, bucket number 13, bucket number 14, bucket number 15, right? We start from 0, that's why 15. Audible?
Yes.
All right, so we can move this thing a little bit. Okay, let's move this and this. Again, it's aligned now. So all right, so this is the buckets that we have, and this is the thing we have, right? Let's suppose I have implemented my hash code method, right? Hash code is just a single method, right? I have written my hash code implementation in such a way. Okay, you will see if we get over here, hash code returns integer, right? Visible? Object class hash code method
Yeah.
returns integer. All right, so that's what I was writing over here, right? Hash code. If I update my hash code, and let's say that hash code returns the value, that key value, right? Key value mod 16. So okay, my bad, mod 16. And how we can like do this thing, right? Now what will be the value I'll get? I'll get value between 0 and 15, right? Mod means just I want remainder. If I divide something with 16, what value can I get as a remainder? 0 to 15, right?
Yeah.
All right, cool.
Math.
So if this is my hash code, and the key I have put is 1, what will be the value of hash code? 1 divided by 16. What will be the remainder?
15.
1. It's not divisible. Remainder will be 1. All right, okay, let's do basic maths again. 17 divided by 16, what will be the remainder?
Okay, here it will be 1. Yeah.
Answer this one.
1, right?
Yes.
Yeah.
And 34 divided by 16, now what will be the remainder?
2.
Yes. And then 32 divided by 16, what will be the remainder?
0.
All right, cool, basic maths. Now what will the remainder of 1 if I use hash code method? 1 divided by 16, right? Remainder will be 1 only.
Yeah.
So the output will be 1. So I will
Yeah.
go to the bucket number 1. All right. And as soon as I do this, first what will happen? It will find out, it will create an entry. All right. Entry is 1 and India, right? This is the entry, right? This is how we save the object, right? I'm audible?
Yeah.
So in which bucket it needs to put the entry it's based on the hash code method, and hash code has returned the 1. Then I'll come to the first bucket and put this value. Clear?
Yeah.
And then let's say I'll come again, and this time I'll say 2, and let's say China, right? Okay, let's say 3 and China, 4 and China. What will happen now? Entry will be created, right? 4 and China, right? Where should I put it now? If my hash code is this method and my value of key is 4, which bucket it's going to go? What's the remainder if I divide 4 by 16?
0.
Okay, cool. So let's do basic math again. 2 divided by 16, 3 divided by 16, and 4 divided by 16. I cannot divide something until that number is equal to 16, right? Because there will be one value, bare minimum 1 I require. If I do 16 into 16, then it's 0, right? More than one value of 16, then I'll get the remainder as 1. Before that, the entire same value will be the remainders. Okay, let me show you, right? Using the code, right? So
Oh, no, I got it. I just confused the numbers
okay.
beside the slash. Got it.
Okay, yeah, but my bad. Okay, I mean, over here in the coding we use mod. All right, so now it will be better. I have used divide, right? My bad. Or all right, so okay, so these are remainders, right? So what will be the value now? 4. Okay, it's Kishore and Vinod. You can also, I mean, answer, right? What will be the value now if I use this hash code? What will be the value of this?
4.
4, right? So I'll go to the 4th position and put this entry object here. All right, Now again there is one more thing. What's a collision in collections, right? Or in Java they can say this thing, right? This thing again comes and boils down to the thing that we are doing right now. So if we if I write 17 and 17 Nepal and Kathmandu. Okay, okay, no, Nepal. Okay, we are not doing the capitals. Okay, so what will happen now? I'm audible.
Yeah.
So 17 mod 16.
1.
Okay, okay. So we'll have a map, and over here it will be 17, and it will be okay. My cat. Okay, just give me 1 second. Please go. Oh, great. So this is the map, and the entry value will be Nepal, right? Nepal, and where we should go at first, right? Because 17 divided by 16, the modular, the remainder will be 1, right? So but there is
Yeah.
already a value over here, right? Visible?
Yes.
This is called collision. If a collision happens, we convert it into a linked list. Visible? This is a link for the next value, next entry.
Okay.
All right.
Yeah.
If another collision happens, then we'll put value over here. All right, by making next. So what is this? What we call a buckets? It's a linked list of linked list. All right, or a list of linked list. All right. Why a list of linked list? Because we can go to this value directly, so it can be array list of a linked list. All right. Clear till now? Now the thing is how the get works, and why we say that it works in O1 time. For O1 time, we'll see the example of this 4. So let's say now I want country.getID.get, and I'm passing value 4. All right. I'm audible? I'm audible? Not you. Just give me 1 second. All right. So if I do this again, the hash code, I'll use the hash code again. Why hash code? Okay, what will be the hash code of this 4? If I'm using this as a method, 4 modulo 16.
4.
So I know I need to go to the bucket 4. So I'll come here, right? And I have the key 4, right? Then I'll check the value in the entry. There is only single entry. I'll check the value whether 4 exists. 4 exists, so I give the value. I'll take the entry object and I'll return the China. Cool. That's how it works in O1 time complexity. Let's suppose in other buckets there are millions of data, but over here there is only 1, so I get the value in the O1 time complexity. Cool. So that's the thing with the get method. But what if there is a collision case like this one, right? How this okay, let's take an example. If I want to get 17, so first it will go to the hash code method, right? Hash code method will provide the bucket number 1. So I'll go to the bucket number 1, and then I need to traverse the entire list. I'll first compare the key with this entry 1. It's not same, right? So I'll move to the next one. So next one I'll try 17 and 17 same, so I'll return the Nepal. So this thing is not log n operation, right? And okay, one more thing. If I'll do country dot get 2, right? It will provide the bucket number 2. There is nothing in the bucket number 2, so I'll return null. All right, so that's also happen. I'll return null over here. If there is no value, then null will be returned, because Java collection works with only objects, and object is not there, default value is null, so that's why it gets null. Now the thing is, if this value, if you tell someone okay, all right, this is the way it happens, then one can ask, okay, if there is collision every time and there can be 1 million rows in the 1 millionth entry in the single bucket, then the time complexity is not O1, right? Because I'm doing manual comparison of the keys over here, right? I'm audible?
Yeah.
So for this case, after Java 8, what happens internally, if a single bucket has more than a threshold number of values, then it converts the linked list, it converts this linked list into a red black tree. And now what's the time complexity of red black tree for searching? Okay, no worries. For red black tree, the time complexity of search is log n. Any tree, if it's balanced, then the maximum worst case time complexity for it will be log n. Alright, so that's why instead of n, if there is for every insertion, if there is a collision, then also the time complexity will be the log n. This happens in version 8, Java 8. Alright, clear till now?
Yeah.
All right, so okay, so this was the last thing. Now let's do one interview question for this, then we'll go to the streams. Okay, set interface map list, just give me 2 minutes.
Yeah.
Okay, so let's do one more question because I know you won't be able to think. All right, so this is also important, the same thing that we have done. We'll just do the practical implementation of it. Map interview. All right, so we have okay, set with or set or map, same thing is there, right? Set with a wrapper. So if I'm doing set with wrapper, so it's obvious that if I create a set, let's say set of integer is a wrapper, right? If I do set of wrapper and I'll say values equals to new as set and add the values dot add 1 and 2 and 3, what will be the output if I print the set? Only 1, 2 and 3, right? There will be no duplicates, right?
Yes.
But if I'll take the student object and put over here toString builder and getter and setter, I'll write in constructors as well. I'll ignore constructor. All right, so okay, and then private string name and private int roll number. All right, so this, and if I create now students, now if I create the student and Dakshita and the student dot okay, why, which student I'm working with? Okay, why okay, my bad. Aula constructor. All right, now it will work. So over here name Dakshita dot and then roll number, let's put 1, then dot build, and we can have 2 more. Alright, let's change the roll number 2 and 3. Alright, so let's take a set and set of a student and students equals to new as set and students dot add Dikshita and okay, so twice Dikshita and then Kishore and then Vinod. All right, what will happen if I print the students now? What will be the, how many students will be there? I'm audible?
Yeah, 3.
And the answer is 4. The Dikshita will be twice. Dikshita. Okay. Oh, my bad. Wait. Oh, right now it's 3. But duplicate Dikshita. Alright. And then duplicate Dikshita. Now how many students should be there?
4.
Why?
Uh,
Roll number 1 and Dikshita can be only one, right? There cannot be 2 roll numbers in a single class.
okay, yeah.
But if,
So
I,
3.
but if I run this, there will be Dikshita here and Dikshita here, right? Roll number 1 Dikshita, roll number 1 Dikshita, right? The difference is in the variable name, right? Not the student.
Okay, yeah.
So this should be same, right?
Yeah.
But it's duplicate. The reason is again same. How it compares the value is hash code, right? The key Dikshita twice are there, right? But the hash code is not working on the Dikshita or the roll number, not the name or the roll number. So it's not going in the same bucket, right? So that's the issue. So for this, what we can do, that's why the question, what's the contract between hash code and equals method. One thing we can do is directly you will see the equals and hash code. It's a annotation also, but right now we don't have to use this because we are learning this thing. So what I'm going to do, I'm going to overwrite method and hash code. So in the hash code, what I'm going to do, I will return simply the roll number because roll number is a primary key, right? So I will return the roll number. Okay. So it will check the bucket based on roll number. Okay. Am I audible?
Yeah.
And the next thing is how it's going to check the value. It was checking this thing, right? Value 1, it was comparing it with the 1, right? We just assume because it's an integer, a primitive integer, so we just assume that okay, it's doing the equals to operator, right? But it's doing the equal to operator, and equal to operator with the objects checks the memory reference, right? And the memory reference was different of this and this because these are 2 students, right? Inside in the build, okay, in the build method it's auto generated. In the build we use the new keyword, so both will have Dikshita and duplicate Dikshita will have different memory places, right? So we cannot use equals of object class because equals of object class will use, okay, let's run this thing, right? In the student.java we have written this thing, so it will reach the same bucket, right? Let's suppose in this there is 1 and this is Dikshita. It will reach the same item, but instead of matching the value of the Dikshita, it will try to match the object reference, so the value will still be invalid. See, Dikshita and Dikshita again, right? Even though we have updated the hash code. So we need to override equals method as well and tell that if this thing happens, then you need to compare. Okay, over here instead of object I want a student. Okay, I want a student object, and in student object I want to compare student dot roll number with the current roll number. Okay, because if roll number is a primary key, right? So we can do it. All right. Okay, we cannot use it. So equals method is taking the object only, so we need to make sure if obj equals to null, then return false. This is a common way of implementing it. If obj instance of student and negation of it. If that's the thing, also return false, else convert it to the student object. Student equals to student and obj, and now compare, now return this dot roll number equal student dot roll number. We have done nothing to compare two student. We must, I mean, if the two students equals or not, first we need to check that both student should be an object, another student should not be null, right? If it's null, then it's pretty sure that it cannot be same, right? And cause this equal method takes an object, so someone can send a teacher also, right, to compare with the student. So if it's not an instance of student, then also both are not same, right? Then if the object is not null and it's an instance of a student, then I can convert it into the student object safely and then compare the roll number of the current student with the roll number of the student that I'm comparing with. So now when I have implemented the equals method of the student class, and then I'll come back again over here and run the code, then you will see there is no duplicate, right? Only one Dikshita now. Visible?
Yeah.
So this is the contract between equals and hash code, or internal working of hash map, put and get. So with this, all right. One thing is left, concurrent hash map. 11:18 already. Okay. See, we have seen in iterators, we have seen the fail fast and fail safe iterator, right? So the fail safe iterator in fail safe collection in map is concurrent hash map, right? We can directly do the same thing, right, while traversing, or if some other thread also wants to update the same code in the multi-thread environment, instead of using normal hash map, we can use the concurrent hash map. All right, so concurrent hash map is a normal class concurrent hash map, right? I'm not writing the code for it. You can just simply go to the code that we have written for the list and then change it with the hash map and use the concurrent hash map. You will get the error with the hash map, not with the concurrent hash map. So how the concurrent hash map reaches in this way, or okay, how concurrent hash map make sure that there is no issue or no duplicates when multiple threads are working on it. So there are two ways in which concurrent hash map works. One is segment wise. So what it do, it blocks a sub segment. Like for example, this is the default 16 size bucket, right? I'm audible?
Yeah.
So what it's going to do, depending on the size of your this map buckets, it will divide this thing in the segments, like 1 to 4 is a segment, 5 to 19 is a segment, and then 10 to 40 15 is a segment. Now if you come here and try to write code in any of this part, then you will take log of this segment only. So another thread can come and does not take log. If another thread comes and wants to update the data in this keys, in these buckets, then it needs to wait. But if it wants to write code in some other bucket, then it can write, because it has been divided into different segments. All right, now the another feature which has been introduced into later versions is each bucket, the segment size will not do the segments. We will keep in the initial, we can have the segments, but as the number of threads or the request increases, we can go up to the single bucket segment wise. And also there is a read and swap algorithm that they use, and based on it we work. All right, so again, it's a later part that you can read on your own when working with it. Am I audible?
Yeah.
Okay, just give me 1 second. Okay, so the last thing left is streams. So streams, okay, so we have already covered streams, right? So the lambdas we were using from the very start. So it's a functional programming lambda we were already working with, and now for the streams also we have seen the major part of it, right? how we okay, we have seen just the basic one while where we were traversing the list. So all right, in the streams, so oh, we have already done with the basics. Okay, okay, cool. So we have seen over here how we traverse. Okay, so the basic stuffs we have already done, and that's the basics. Okay, cool. So this thing, everyone is able to understand this thing, right? What we are doing?
Yeah.
Okay. So what we were doing, stream basic runner. Okay. So we can say, okay, in how many ways you can create the stream? Ways, like ways to create thread, ways to create a stream runner. So one way we have already seen, right? Arrays dot as list, and then I can simply put 1, 2 and 3, right? And then I can do stream. So is this returns me a stream object, right? Then for streams I can traverse. For each value in the stream I want to print it. All right, so I want to print the value and a comma later on and no next line. So if I run this, 1, 2, 3 visible. Same thing, entire same thing. Instead of array.asList, I can do list.off. All right. Okay. What's the difference between these two? List.off is introduced in the 9th version. All right, but it's okay. Okay, my bad. Let me run it again. Okay, one sysout is required. So one with the array.asList, and then this another one is with list.off, and these are the list implementations, right? So if I'll do, okay, my bad. So okay, we can do it hash map and put the list here. Okay, arrays.asList 1, 2 and 3. Okay, and okay, don't return anything, shit. Cannot directly use the object. Okay, one more this. Why it's not, why it's showing error, cannot resolve hash map listy. Okay, hash set, my bad, hash set. All right, now it's fine. Okay, we can mark it off integer, and then I can open the stream. This is a stream of set, right? And over here as well, for each I can do the same thing, value sysout, and then the value plus and comma println. This is with, okay, and the sysout is required. This is for set. So 1, 2, 3 we have printed for arrays.asList, set and map. Oh sorry, set and list.off. Is the basic, right? We have done this earlier also. Am I audible?
Yeah.
So this is collection to stream. All right. So what's the alternative of collection? Primitive data types, right? And a group of primitive data type will be primitive array, right? Integer array equals to new integer, and then 1, 2 and 3, right? This is an integer implementation, right?
Yes.
So what if I want to get the stream of this? Arrays dot stream, and then I put the primitive array. Oh my bad, primitive array. Then same thing. Then okay, then I can get stream array dot stream. Okay, it's returning the in stream. Okay. In stream is a specialized version of stream. And then, but on the in stream also, it don't have the same functionalities as of the stream, but it still have different functions that we can use. So over here we can use the iterators and other things. We cannot open the stream because it's already opened the streams. And also for each, the same thing that I've done earlier, we can do it. If I run this now, okay, sysout needs to be printed. Sysout primitive array to stream. Okay, primitive array to stream. For before this also sysout. Okay, clear till now? How can we convert primitive data type to streams? Hello.
Yeah.
All right. Directly using stream, right? So while I'm doing this, I'm creating a linked list, then I'm opening a stream, right? If I have to do, if I'm creating already a collection, isn't it better if I'm able to create directly a stream? Why to create intermediary thing and then directly just copy this. Okay, need to print this also. Stream object direct instantiation. All right, see, same output, right?
Yeah.
So in this manner we can create the streams. These are the ways in which if you want to create the stream we can, but most of the cases we'll have a stream object already or collection object already, and then we'll be working on it. So ways to create a stream. And then operations, there are different operations that we can do. So stream, okay, filter, okay, stream operations, these are the most important item, right? We are going to cover one interview question as well, and then we'll end it. So let's say we have a string of integer, or should we directly take something else? Okay, we can take integer only, and we can take numbers. I have a list of integer where I have numbers and arrays dot slist 1 2 3 4 5 6 7 and 8, right? So first thing that I want to do, these are called intermediate operations. I want to filter out numbers, and I only want odd number or even number. I want these things. So how can I do it? I will just use numbers, and I'll open its stream, so I'll get one by one every number, and then I'll filter the stream. And how can I filter? Whatever value I'm getting, I'll check if the value is mod 2 is equals 0, right? This means it's an even number, right? I'm audible?
Yeah.
So but I want another stream of it. Okay, same numbers I can use, same numbers object I can use. Okay, let's not make you confused, and let's take another list, and we can say that even numbers. So on the numbers stream, on the numbers collection, I have opened a stream, and I filtered value, and I've taken only those values which modulus is after dividing by 2 is 0. So I can collect it directly by the collectors API, collector.toList. So now if I print numbers over numbers and even numbers and just even numbers here, and run the code. Okay, my bad. You will see numbers have 1 2 3 4 5 6 to 8, and the even numbers have 2 and 4, 6, 8 only. So how it internally works is, when I open the stream, it sends the data one by one in the value part, right? It returns the value, it returns 1 to the value, and the value did this operation, and the modulus was not 0, it was 1. So the filter also returns a stream object, right? So in the next stream, the filter object will not add 1, because filter returns a stream, right? And inside it we have a predicate. I'm not going to dive deep into these things, but our predicate and all. Predicate, I mean, in the simple language, predicates take a statement which needs to return boolean value. So if I don't write in the filter something that returns a boolean value like this, if I'll just try to write something else like system sysout abc, now there will be an error if I run this. Incompatible types, bat return type lambda expression. Void cannot return boolean true, right? So the predicates require boolean object. So the value modulus 2 is boolean, and whichever value is able to return the true at your lambda expression, this is the lambda expression that we have added, that thing will be collected in the stream and will be passed on to the collect next function. So the collect will only get even numbers 2, 4, 6 and 8, because it has been filtered out in the second phase. Clear? Am I audible?
Yeah.
All right. So next thing is, if these are the values, what if I want to operate more on it? Like the number, we already have the numbers, right? So let's again open the streams, and then this time I also want integer only, but I want to change. Okay, let's take some different example then. So this example was of, again, interview question, right? Filter odd numbers. All right, over here the next example will be of a string, and over here we will operate on the string. It can be names, and then same arrays dot as list, then it can be, give me 1 second. It will be all your names in the small case, and then I'm going to convert it into the caps. All right, let's go ahead. And okay, let's just take a single strings a and b and c. Why to write a lot of names again and again? All right, okay, not character, string a and b and c. This is the names, right? Again I want names, but uppercase. So I have the names streams already, right? Then I'll start a stream, then I'll map. All right, if I want to modify, if I want to filter out something, then I will use filter method. If I want to make any modifications, then I need to use map. Then I'll take in the stream, I will get a string, right? So string, I can get name. Okay, let's take the name, no worries. Thou and sure and all right, so I'll get the name, and what I want to do with the name, I want to map it with the name dot to uppercase. Simple. I'm audible?
Yeah.
And then if I want to collect it, same thing, collectors dot to list, right? And it can be a set also, collectors dot to set, right? It depends on you what you want. You want set, you can get a set also. We can do the list. And uppercase names we have now, case names names we have, and then simply sys out and names, and then sys out, okay, yes, uppercase names. All right, let's run the code. This was the earlier name, this is the modified name. All right, even if I take the same example, after filtering out this thing, let's say that I want to multiply the filtered number by 10. All right, so instead of getting 2 4 6 and 8, I want 20 40 60 80, right? So what can I do? I want to modify, right? If I want to just filter out, I will use filter. If I want to modify, then I will use map, and map I'll get value, right? So I'll get now filtered value, so only even number I'll get, right, over here. So I'll say that even number, and I will do even number into 10, and then dot collect. All right, so over here it's number, even number multiplied by 10. Now if I'll just print this thing, you will see this was the numbers and this is the modified numbers, which was filtered first for even and then modified and multiplied by 10. So it's 20 40 60 80. Clear? Am I audible?
Yeah.
Okay, so now another thing, if I have a list, so again, okay, we can take the numbers again. Let's a new number, list integer, unsorted list, new array list, 1 2, okay, arrays list, arrays dot as list 1 3 4 2 4 and 5. All right, this is unsorted list. Visible? So this unsorted list, if I want to make sure that okay, let's sort this unsorted list stream. All right, then because it already implements the sorted interface, because sorted will use comparable or comparator. I'm audible? Which thing it will use, comparator or comparable? Comparator needs to be created. Comparator is by default implemented by the wrapper classes comparable. So now the sorted list and plus and sorted list. If we run this now, 1 3 2 4 5 was there earlier, 1 2 3 4 5 after sorting. All right, but make sure your class is comparable. Am I audible?
Yeah.
Last thing, let's do find the distinct. We can do a lot of stuff, right, with this, and in the distinct I don't want to do anything else. I want to list a single integer and distinct, okay, duplicates, and then arrays dot as list 1 1 2 3 4 3 and 4 and 5 5 5, okay, and 5 5 and 5. This is duplicates, right? Duplicates, and then just simply plus duplicates, and over here, okay, well, okay, 1141. So these are the duplicates values, and then non-duplicates values. So duplicates dot simple stream dot distinct, and then collect as a list, and list integer distinct values and distinct values. So you will see duplicate list 1 2 multiple times 1 and multiple times 3 multiple times 5. So over here only a single time, right? Little now. Hello.
Yeah.
So now you can do one more, you can do find operations as well. So simply you have list of, let's say 1 2 and 3, right? And then I'm trying to open streams and I'm trying to find any, right? So find any student, find any, but what will take, if you want to find anything value, okay, find any, you need to go inside and check what you have. If I'll try to add one, there is an issue, right? Or find first, you need to value and value equal to. I'm audible?
Yeah.
And now you will see this is find first. Find first operation will provide me the optional, right? But the thing is, this operation find first, find any will provide you, okay, optional is also something that we are not covering in this course. So you will not get the complete, okay, you will not, it's not guaranteed that you will get something. And find first is not something that going to filter out some value. This will just return as soon as you'll get some value. This is not, this is okay. Okay, wait, see, there are some terminal operations. Terminal operations are the methods that will end the code, like this collector dot to list, right? This stream is creating a stream, distinct is also returning the stream, right? You are not getting anything concrete. Map sorted also stream, right? Then filter also stream, right? The map also stream, right? Where we are getting some value, we are getting value in the collectors dot to list. So collect method is returning the value right over here, different value that we want, a list of something, which list we want, and we are getting the list, right? To list returning the collection of list. So that's the thing, these are called the operations or the methods that ends our stream are called terminal operations. Am I audible? So
Yeah.
find any is not a terminal, it's a terminal operation, but it will end your processing in the midway. But you want to, it will return the value as soon as you'll get it. Like in the find first, I need to filter the value, filter the value. And if I'll say that any value greater than 2, so in the find first I'll say value, in the filter I need to value, right? Value greater than 2, visible? Okay, why? So okay, find first, not filter. All right, filter. So right now over here, if I'll say get directly, right? Never use get directly, int value, and I'll just print out sys out value greater than 2, first value greater than 2. So value, which will be the first value greater than 2. Okay, variable value is already defined, so let's make it well and well. All right, let's run this. So value greater than 2 is 3, right? So over here what we can do, we can add 4, 5 and 6 also. Okay, so now we get 4, because after 1 and 2 the third value will be 4, right? A list will preserve the insertion order, so it will start from here, and then it will reach 4, and 4 is greater than 2, so it will provide the value 2. We can even change the places, we can put the 4 over here and then run it. Now we will get 5. So what's happening over here, when I'm using the find first, it is not reading more values from here. It's not reading 4 and 6. As soon as it gets any match, it will return it. Find first. Am I audible?
Yeah.
So these are the operations that we can do in this. Now the thing is, now you can play it on your own, right? You can play with this thing and try to create how the question is asked. You will be provided a list of students, and now you need to sort the student based on their roll number. This can be first thing, right? You can do it with sorting. Another question can be, you are having a student, you are having a list of employees, and you need to get a list of employees who resides in Noida and have a salary greater than 10,000 or 40,000 per month. So what you are going to do, you are going to write filter that the student or the employee dot get office location equals to Noida, or dot equals Noida, and you can write multiple filters, or in a single filter you can add two conditions, and employee dot get salary should be greater than 40,000. Then you can get a list of employees who are earning more than 40,000 and who are working from Noida. And the next question can be, give a list of employees, get a list of employee names only from a list of employee objects, and the condition will remain same, that the employees is working from Noida and has a salary greater than 40,000. Over there you will put one filter where the salary should be greater than 40,000, another filter where the salary should be where the job location should be Noida, and then you will use map, and use the student employee dot get name. Okay, it will hardly take 2 minutes. Let me write it down. So let's create an object of employee. Alright. So over here, okay, wait, let's write the name. Private id, emp id, private string name, private, and then let's say department. Okay, salary, and salary. All right, and we can say private department, private string department also, department, and at the rate builder, at the rate Ola constructor, at the rate Nova constructor, at the rate getter, and at the rate setter. This is the last question that we are doing, then we'll end the session. And then okay, employee runner, stream runner, very commonly asked question, interview question. So need to create employee, and okay, let's take some other name. So let's say Ram, and employee, okay, and then give name will be Ram, and employee will be 1, and department, let's say technology, and something else, salary, let's say 1 stents 100,000. Okay, let's say 1 stents 100,000, 10,000 lakh, and let's create 2 more employees, and let's put it into HR, and then 1 stents 100,000, 10,000. Okay, and then Lakshman technology, 1 stents 100,000, 10,000 lakh. All right, and then one more person less than 40,000, Ravan, and okay, no, let's say Bheem, and Bheem is in support, and have salary of 3,000. Okay, and over here is Lakshman, and over here is Shyam. YM employee IDs needs to be changed also, 2, 3, and 4. Okay, now a list of employees, and employees, and list dot marked employees dot add Ram, Shyam, Lakshman, and Bheem. So this, if I print the employees first, let's see the output. These, okay, toString also needs to be implemented. toStrings. All right, let's go back. Let's run the code again. So we'll see in the employee Ram, Sham, Lakshman and Bhim, right? Okay, location, I haven't used location, right? Let's use location also. Okay, location I haven't put in this thing. Okay, cool, no worries. We'll use, instead of location, we'll use the department. So we need employee list from technology department. All right, so how can I get it? List of employee technology employee equals to employees dot stream dot filter employee. I'm getting employee object, so employee object get department dot equals, let me just copy paste this, technology, and simply collectors dot to list. Okay, my bad. Collectors to list and simple print technology employee. All right, this will be the technology employee. Let's run it. So technology employee is Ram and Lakshman. Cool. Now I want a technology employee who's earning more than 4 lakhs. And I only, okay, let's change the thing. I want employees who are earning more than 60. Okay, I want technology employee who's earning more than 4 lakhs. All right, and just his name, not the entire employee object. So the same thing I'm going to do. List of string, I want list of string high value employees, and then I'll say employees dot stream and that filter. So first filter I can put employee, then employee get department, and then technology. Same thing that I have used over here. All right, and then I'll use another filter and do employee, and that employee dot get salary should be greater than 100,000, 2,000 lakh. And now map whichever employee I have, I just want its name, employee dot get name, and I will collect it to list. All right, employee dot get department and technology. Okay, my bad. Dot equals technology over here, and now I'll just simply sys out high value employees. There is only one high value employee right now. I guess it's Lakshman. Let's see. Lakshman. Visual.
Yeah.
So that's how. This is exactly purely interview question that has been asked to me also. I mean earlier, not now. So these are the interview questions that usually ask. There are other also, but we're not going to cover those things. So you can just play around with these and try to inculcate it during your normal production code or your freelance or your normal practice code as well, and then you will be good to go, right? And it's going to take some time, right? You to know that okay, filter need to pass boolean, right? Because it's predicate inside. Then in the map you need to write the function, right, to convert to some other data. You can have the same data as well, right? You can convert from string to stream also, and there is no issue with that also. You can modify. We have done the same thing, right? From the string. Okay, in the last one example we have not converted from different example string operation runner. Over here it was a string, and then we converted into string only, a string to map string only, right? It's not like we have to change the data type or the object type. We can keep the same, but it will create a list of some different or the collection or the stream of some different data type as well. The filter can only will filter out the data. If you want to convert the data, then you need to use the map. If you want to sort the data, then you need to use the sorted. If you want to distinct data, you can use the distinct, and that's it. And these are the basic functions that you can do in both and the other